Did you know that temperature-related issues contribute to nearly 40% of infrastructure failures worldwide? From cracked roads to weakened bridges, temperature fluctuations are a silent force undermining the stability of our most critical structures. Welcome to another episode of the Geotechnical Engineering Podcast. I'm your host, Jared Green, and in today's episode, we're exploring the fascinating world of temperature sensors and maintaining the health and resilience of our infrastructure. From bridges to buildings, temperature fluctuations can significantly impact the structural integrity of our essential assets. We'll uncover how geotechnical engineers use cutting-edge technology to address these challenges and ensure infrastructure remains resilient in the face of climate change. So with that, let's dive right into today's episode.
Before we dive in, we'd like to recognize our sponsor for this episode, PPI, a leader in engineering exam prep for the FE and PE exams. PPI provides expert prep courses and study resources designed to help you pass the FE and PE exams the first time. PPI's live online courses include hours of lectures, problem-solving demonstrations, exam strategy sessions, office hours, and a passing guarantee. Check out PPI today at ppi2pass.com to see all the options available for FE and PE exam prep. Now let's dive into today's episode.
The impact of temperature on infrastructure. Let's start by talking about how temperature impacts infrastructure. It's easy to think of bridges, roads, and tunnels as static, unchanging structures, but the truth is they're constantly being affected by the surrounding environment, especially by temperature fluctuations. When the temperature drops, the materials used in construction, whether it's concrete, steel, or asphalt, shrink. When the temperature rises, these materials expand. While this might sound like a simple process, over time, these constant fluctuations can weaken infrastructure, leading to cracks, deterioration, or even catastrophic failures. Take concrete roads for an example. In cold weather, the concrete contracts, which increases the risk of cracking. And these cracks are more than just cosmetic. They can lead to serious damage that compromises the road's entire structure. Bridges and tunnels face similar issues with expansion and contraction, putting stress on critical components like abutments and piers. And it's not just what we see on the surface, but beneath our feet, temperature changes also affect the soil that surrounds these structures. When the soil expands and contracts, it alters its load-bearing capacity, which can be especially dangerous in areas with permafrost. As the soil thaws and the ground shifts, and that shifting can destabilize structures that are built on top of it. This is a growing issue in regions that are heavily affected by climate change, where permafrost is melting faster than ever. How temperature sensors help maintain infrastructure health. So how do we tackle these temperature-related challenges? The answer lies in technology, specifically temperature sensors. These sensors are like the eyes and ears of our infrastructure, constantly monitoring the temperature of materials and soil, providing real-time data that helps engineers make informed decisions about maintenance, repairs, and even design adjustments. There are several types of sensors, like thermocouples and thermistors, that can measure temperature in their surroundings. Once the data is collected, it's sent to engineers who analyze it, looking for trends or warning signs of potential issues. Let's take tunnels, for instance. Temperature sensors can monitor the air, the walls, and the surrounding soil, which would give us critical information to prevent overheating, which can lead to fire hazards, and also helping to avoid structural degradation caused by temperature changes. Similarly, in bridges, these sensors track the temperature of key components like pavement, piers, and abutments. Catching a potential issue early makes repairs cheaper and easier, which helps extend the lifespan of these critical structures. Real-world applications of temperature sensors. Let's take a look at a real-world example of how temperature sensors have made a difference. During a recent rehabilitation project on the San Francisco-Oakland Bay Bridge, engineers installed temperature sensors to monitor the bridge's foundation. Thanks to the data collection from these sensors, they were able to spot design weaknesses before they became costly issues. This allowed them to make adjustments, saving millions of dollars and extending the bridge's lifespan. But it's not just about catching problems early. Temperature data also helps engineers optimize the timing of maintenance. By understanding how temperature fluctuates throughout the year, repairs can be scheduled during periods of low usage or before any serious damage occurs, which reduces costs and minimizes disruptions. In conclusion, temperature sensors are transforming the way we think about infrastructure resilience, whether it's roads, bridges, tunnels, or buildings. These sensors provide vital data that helps us prevent failures, optimize maintenance, and extend the lifespan of our infrastructure. And with climate change increasing the frequency and severity of temperature fluctuations, their role is more important now than ever before. By incorporating temperature sensors into our infrastructure monitoring system, we're not only ensuring that our structures remain functional, we're making them more resilient, efficient, and sustainable. So, as we look towards the future, let's continue to embrace these technologies and build a stronger, more resilient tomorrow. I hope you enjoyed the episode today. We would love to hear your feedback, comments, and/or questions. Please feel free to go to geotechnicalengineeringpodcast.com, where you'll find a summary of the key points discussed in today's episode, as well as links to any of the resources, websites, or books mentioned during this episode. Until next time, we wish you the very best in all of your geotechnical engineering endeavors. Peace.